1 of every 4 deaths in the United States is from cancer, causing 564,000 Americans to die each year. Despite these shocking statistics, there is now a 58% survival rate of those diagnosed with cancer. Treatment for this relentless disease is only possible thanks to the work of Marie Curie and the discovery of radium. During the 1900s, Marie Curie overcame discrimination in the male-dominated fields of science and medicine. Her discovery of the elements radium and polonium opened the doors for future female scientists in both disciplines. For these discoveries, she became the first woman to ever win a Nobel Prize. Marie Curie's leadership began in World War I as she developed X-ray-equipped vehicles to assist wounded soldiers. The continued research on her discoveries became legendary as she laid the groundwork for a potential cure for cancer, which would change science forever. Marie Sklodowski grew up in Warsaw, Poland during the late 1800s. Her parents were very prominent teachers, but also members of the lower end of society. Poland was under Tsarist Russian control, where social stratification was common and the higher education of women was disallowed. Despite this, they wanted Marie to receive the same education as someone in the upper class. After regular schooling, she pursued a higher education at the University of Paris, but like most universities in Poland, they did not accept women at the time. Marie and her sister decided to attend a floating college. This illegal college got its name because it changed class locations so often that it would be hard for the czars to find them. After her time at the floating college, Maria continued her education at the Sorbonne in 1891. She was one of only 23 women in a school controlled by thousands of men, but still ended up graduating with degrees in mathematical science and chemistry, both male-dominated fields. During her time at the university, she met a professor of physics by the name of Pierre Curie in 1894 and married the next year. A doctoral thesis was the last thing she needed to graduate from the Sorbonne. Her thesis was founded on 2 recent discoveries in the scientific community. First, in December 1895, about 6 months after the Curies married, German physicist Wilhelm Röntgen discovered a kind of ray that could travel through solid wood or flesh and yield photographs of bones. Röntgen named these mysterious rays X-rays. A few months later, a scientist named Henry Becquerel was doing experiments of his own. He believed that elements that glow emit the elusive X-ray, and he was correct. What was then known as Becquerel rays is now more widely known as radioactivity. This work was the basis of Marie's thesis. She wanted to know which elements emit Becquerel rays. Marie put an earlier invention, the Curie electrometer, to use in measuring the faint currents that can pass through the air that have been bombarded with Becquerel rays. With multiple experiments, she found out that no matter what form uranium was in, whether it is solid, dust, pure, or in a compound, it still emitted radiation. Pierre was very interested and joined Marie in her work. Her research had revealed that a uranium or pitchblende was much more radioactive than pure uranium itself. Marie wanted to find out what was in the mysterious pitchblende that made it so radioactive. Marie was delivered 10 tons of the ore by the Australian government, which began a long period of study. The Curies realized they had to separate the elements in the pitchblende to study each independently. They discovered that depending on the amount of thorium or uranium it contained directly related to the amount of radioactivity. In July 1898, the Curies found that a part of the pitchblende contained a new element. Chemically, it acted almost exactly like bismuth, but since it was radioactive, it had to be something new. They named it polonium in honor of the country of Marie's birth, Poland. Then, in December of the same year, they discovered a new element in the barium section of the pitchblende. They titled it radium because it is 2.7 times more radioactive than the same amount of uranium. She was only able to obtain 1/10 of a gram of radium in 10 tons of pitchblende. Little did she know, this was a scientific encounter that would soon become part of her legacy. But first, she had to isolate the element for it to be recognized in the scientific community. 4 years later, she presented her findings in 1903, becoming the first woman at the University of Paris to obtain her doctorate.
So she not only led by the work that she did, she also led in the way that she interacted with other people. Even though she was markedly discriminated against as a woman, her legacy is a dramatic one. She basically helped us understand how radiation works.
Her new discovery awarded Marie, Pierre, and Henri Becquerel with a Nobel Prize in Physics and Chemistry for the advancement of science by the discovery of radium and polonium. Marie Curie became the first woman to not only win a Nobel Prize, but to win two in different sciences. She remains the only person in history, male or female, to accomplish this feat. All her life, Marie Curie was repressed by a world dominated by men, and in this moment, she felt equal.
I think her accomplishments as a woman at a time when men looked at women as inferior is probably larger than her scientific feats, which is saying a lot, because her scientific feats are enormous. But being the first woman to win a Nobel Prize, being the first person to win two Nobel Prizes, she had a tremendous impact on how women were perceived.
In 1906, Pierre Curie died, causing Marie to replace her husband as the professor of physics at the Sorbonne. Marie later gave her first lecture on November 5, 1906, thus making her the first woman to become professor in the 650-year history of the university. During the year 1914, the world was on the cusp of war, and Marie Curie wanted to use her scientific genius to assist France in winning the war. Marie stated,
"I am resolved to put all my strength at the service of my adopted country, since I cannot do anything for my unfortunate native country just now."
She used her knowledge from her previous work to personally equip 20 vans with X-ray machines that could be mobile and used on site. Enlisted men would soon call these Petite Curies, which would be used to treat shrapnel and fracture wounds on the battlefield. By the end of the war, she created over 200 X-ray stations in France and treated more than 1.5 million soldiers of France and their allies. Marie also helped develop the Radium Institute in both Paris and her hometown of Warsaw to continue the research on radium. Marie Curie's 67-year journey ended in France on July 4, 1934. She died of an aplastic anemia, a blood disease that often results from exposure to large amounts of radiation. Later, on April 19, 1995, Marie and Pierre were moved from their original resting place to the Pantheon in Paris. Marie is the only woman to be buried there, but will be joined by two more women who will be laid to rest in May of 2015. As advancements were made, the deadly poison emitted by radiation is now controlled safely. We can use it for medical purposes more effectively using developed technology. Marie Curie's leadership in discovering radium has created a new branch of science, radiology, that now employs millions of people. There are X-ray machines for seeing bones, CT scans for producing cross-sectional images of the body using X-rays in a computer, and MRI scans for observing organs and structures inside the body. Along with viewing the inside of the body, there is therapeutic radiology, which treats cancer. Radiation therapy uses special equipment to send high doses of radiation to the cancer cells. Most cells in the body grow and divide to form new cells, but cancer cells grow and divide faster than many of the normal cells around them. Radiation works by making small breaks in the DNA inside cells to reduce the spread of the diseased cells. This innovative discovery has led to a 58% cancer survival rate, a number which is on the rise.
She also figured out that radioactivity damages cells like cancer cells. So she figured out, so that is used every day. The radioactivity from radium and other radioactive sources are used to not only image the body, but to help do therapeutic treatments of patients who have cancers.
Along with her medical legacy, Marie Curie's success urged other women to pursue a career in science, such as Irene Curie, who later won her own Nobel Prize by improving her mother's work, and Gertie Theresa Curie, a biochemist who was inspired to win her own Nobel Prize because of Marie Curie's leadership in showing that women are equal in all disciplines. The long-lasting legacy of Marie Curie has caused more than 47 women to win a Nobel Prize.
And I think if it weren't for Marie Curie and the influences she had on the scientific world in terms of seeing women as capable, we wouldn't have had the kind of progress we've had in women's rights.
Her life will be celebrated and remembered for eternity because of her impacts in science. She refused to do what was expected of her in society as a woman and changed the future for all females by proving that women can overcome discriminatory barriers.